Archimedes Principle. Here we have a Newton meter supporting an object over a beaker of water. Below this is another container on an electronic balance. At the moment the Newton meter reads 7 newtons, so I'm going to call that W1, and the electronic balance reads 250 grams, so I'm going to call that M1. As we lower the object into the water, water is displaced, filling the lower container. The Newton meter reading now goes down to 4 newtons, which I'll call W2, and the electronic balance has gone up to 556 grams, which I'll call M2. So the weight of the object appears to have changed because it's in the water. We can find out the value from W1 minus W2, which is in this case 7 newtons minus 4 newtons. The weight has changed by 3 newtons. Let's look at the amount of water displaced. Well, M2 minus M1 gives us the mass of water displaced, which is 556 grams minus 250 grams. We've displaced 306 grams of water. To find the weight of water, well, the weight of an object is its mass in kilograms multiplied by the gravitational field strength, 9.81 newtons per kilogram, which in this case is 306 times 10 to the minus 3 kilograms, as a gram is a thousandth of a kilogram, multiplied by 9.81 newtons per kilogram, gives a weight of water of 3 newtons. This then gives us Archimedes' principle, that an object in a fluid, which is a liquid or a gas, experiences an upwards force, which we call upthrust, and this is equal to the weight of fluid it displaces. Now to look at why some objects float while others sink. Water has a density of 1 gram per cubic centimetre. Here is a 1 centimetre cube with a mass of 0.8 grams, and therefore a lower density than water. The object floats. If an object has a lower density than water, the density of water being 1 gram per cubic centimetre, it will displace its own weight in water before it is fully submerged, and will therefore float. This 1 centimetre cube has a mass of 1.2 grams, therefore a greater density than water. It sinks because it has a higher density than water, and so will not displace its own weight in water even when fully submerged, and will therefore sink. You probably know that it's easier to float in the sea than it is in fresh water, and here we have two identical objects, and you'll see that the object in pure water floats but at a lower level than the object in salt water. The reason being is that salt water has a higher density than pure water, so an object needs to displace less water to match its weight and therefore float. So objects will float higher in seawater than in pure water. Here we have an ice cube made of pure water on the left and made of salt water on the right, both floating in salt water. The pure ice cube floats higher, as it is a combination of the lower density of the water and the crystalline structure of ice that gives it a lower density than the salt water it floats in. The salt water ice cube floats lower down. It is just the crystalline structure of the ice giving it a lower density than the salt water it is in. Both cubes are displacing their own weight in water, allowing them to float, but when the pure ice cube melts, it will produce a bigger volume of water than the salt water it is currently displacing, and so the water level will rise. When the salt ice cube melts, it will produce the same volume of water as that it is currently displacing, and so the water level will not rise. A saltwater iceberg will not raise sea levels when it melts, as it is made up of water with the same density as the sea, whereas a pure water iceberg will raise sea levels as it melts, because it is made up of water with a lower density than the sea.